Hello and welcome students to another video lesson for pre-high school mathematics. In today's class, we'll discuss about the topic cubes and cube roots. So we'll discuss that what are the properties of cube of a number and how we can find the cube of a given number, and further we'll discuss the properties of cube roots as we discussed in our previous chapter, squares and square roots. So let's see what we have to know regarding this chapter and what are the topics that we need to understand. So hopefully at the end of this module and this lesson, you will be able to understand these following concepts. First one is identify the cubes, then identify the prime numbers to apply the prime factorization method. Then we have a list the properties of the cube and identify the cube root, differentiate between cube and cube root, and further we have to discuss calculate cube root of a perfect cube without using prime factorization. Then further we can start with the very first concept, that is all about perfect cubes. Okay, so what we understand by perfect cube, so the cube of a number is the number raised to the power 3. Okay, for example, volume of a cube. So as all of you know that cube is a solid figure. It is a 3D shape which is having 6 faces and 8 vertices. Okay, as we discussed in our chapter, visualizing solid shapes. So volume of a cube is side into side into side. For example, we are having a cubical box or cubical dice whose length of each side is 5 centimeters. Okay, so in that case, the volume of that dice or that cubical box, that will be equal to 125 centimeters cube, or whatever unit we are taking over there. Okay, so volume of cube is s to the power 3. Okay, where s is the length of the side of the cube. So what we can say from here, that when a number is multiplied by itself 3 times, we get the cube of the number. For example, the cube of 2 will be 2 cube, 2 into 2 into 2, that is equal to 8. Okay, similarly the cube of 5 is 5 cube, 5 into 5 into 5, that is 125. So in this way, we can easily find the cube of a given number. Further, what we can say that 8 and 27 are natural numbers, which are cubes of natural numbers 2 and 3 respectively. So such numbers are called as cubic numbers. Okay, so 8, 27. Okay, then for example, for 4, we'll get 64. So 8, 27, 64, such type of numbers are called as cubic numbers. Then, for example, what is the least number that 500 must be multiplied to make it a perfect cube? So let's see the solution over here. So we have seen that 500, the factors of 500 we can find easily, that we have already learned in our previous chapter of square roots. So the factors of 500 will be prime factors, we can say, that is 2 into 2 into 5 into 5 into 5. Okay, so what we have to do, we have to multiply. All of you can see that we are getting one pair of triplets for 5. Okay, but we are not able to get a triplet of 2 also. Okay, so in case of square, what we are doing, we are making pair of double numbers. Okay, or we can say pair of two numbers which we are getting in the prime factorization. But here we have to find triplets of given factors of that particular number. So here we are getting the triplet of 5 initially, but we are not able to get the triplet of 2, which means that we have to multiply 2, okay, on both the sides. So what we can observe over here, that if you are multiplying 2 on the right hand side as well as the left hand side, what we are getting 2 cube into 5 cube. Okay, and on the left hand side, when you will multiply 500 into 2, we'll get 1000. So 1000 is a perfect cube for 10, because when we are multiplying 10 into 10 into 10, we'll get 1000, which is a perfect cube. Okay, so in that case, we have seen that we have to multiply by 2 on both the sides to make 500 a perfect cube. Second example is, what is the smallest number that 686 must be divided by to make it a perfect cube? So first step, all of you know that we have to find the prime factors for 686. The prime factors will be 2 into 7 into 7 into 7. So all of you can observe that we are getting a triple, or we are getting a triplet of 7, but triplet of 2 is not here, it is missing. So we need to make what we have to do, we have to remove this 2 from here so that we can make 686 a perfect square. So what we can observe from here, we can divide both the sides of the equation by 2 to make it a perfect square. So when you will divide 686 by 2, okay, and on the right hand side also, then we'll get how much we'll get 686 by 2, whatever you will get from there, okay, that will be a perfect square. So you will get 343. So 343 is a perfect cube for 7, because 7 into 7 into 7 will get 343. Okay, let's see some properties now regarding cubes of numbers. So first property is cubes of even and odd numbers. So we'll see that the first one is, if an even number is multiplied by itself 3 times, the result is an even number only. For example, 2 into 2 into 2 we are getting 8. Similarly, for 6 we are getting 216, and for 12 cube we are getting 1728. So all these examples in which you can observe that we are getting only an even number. Okay, then second property is regarding odd numbers. So when an odd number is multiplied by itself 3 times, the result is an odd number. Okay, example you can see for 3, for 7, for 11, when we are making it cube of these numbers, okay, multiplying by the same number 3 times, we are getting odd numbers only. So these properties you have to remember regarding the cube of even numbers and odd numbers. Okay, so what we can conclude from here, that the cube of an even natural number is even, and the cube of an odd natural number is odd. So these two properties you have to uh, keep in your notes over there. Next, we'll discuss the cube of a negative integer. Okay, so look at the products given below. -1 cube is equals to -1 into -1 into -1. So in the previous case, when we were squaring a negative number, so negative number, whenever you are squaring that, it always becomes positive. But we can say that square of a negative number is always positive, but the cube of a negative number is always negative. So here what we are getting, -1 as the answer. Similarly, -5 into -5 into -5 is -125, but -5 square is 25. But again, if you are multiplying that with 5, then again plus into minus will get minus. That's why what we can conclude from here, that the cube of a negative integer, or we can say the cube of a negative integer, is always a negative integer. So for example, same we can observe for -10 also. So for -10 cube, we are getting that -1000. So we can conclude from here that the cube of a negative integer is always negative. Next, we have the cube of a rational number. So rational number, all of you know, which can be expressed in the form of p by q or a by b, where b is not equal to 0, right? So it is given by, for example, we have to find the cube root of cube of this rational number a by b. So we can write as a by b whole cube, which is equal to a cube by b cube. Okay, so in this way we can find the cubes of rational numbers. Next concept is about regarding cube roots. Okay, so the properties of cubes we understood. Okay, now let's move to the next important concept of cube roots. Okay, so as discussed in the chapter of square roots, in the similar fashion we'll detail it for the cube root also. So if the cube of 2 is 8, then 2 is said to be the cube root of 8. Okay, so similarly we denote cube root by the symbol, the same square root symbol over there, but we have to mention 3 to the beside the symbol of the square root. Okay, which means that it is not a square root, but it is a cube root. So symbol, all of you can observe. So this is the symbol of cube root. For example, the cube root of 8 is 2. Similarly, the cube root of 27 is 3, and the cube root of 64 is 4, and the cube root of 1000 is 10. Okay, next, the cube root of a given number is the number whose cube is equal to the given number. Okay, because all of you know that 10 cube is 1000. That's why cube root of 1000 will be 10, just the reverse of that. So cube root of a cube of 4 is 64. That's why the cube root of 64 will be 4. Similarly, the cube of 5 is 125. So cube root of 125 will be 5. Okay, next property we'll discuss about cube root of a perfect cube by prime factorization method. So as we discussed in our previous chapter, that how we were able to find the square roots of any given number with the help of prime factorization method. Now we'll discuss that how we can find the cube root of a perfect cube by using prime factorization method. So methods are similar. Just over here, we have to make triplets, okay, triples of the factors. In case of square roots, we are making doublets over there. So here, let's see with the help of an example. The cube root we have to find for the number 1728. Okay, the first step is carry out the prime factorization of the given number. So 1728, we can find the factors. 2 is coming how many times? 1, 2, 3, 4, 5, 6. So we are getting 6 times 2 into 3 times 3. So all of you can easily observe that we are getting triples, okay? Triples of 2, two pairs of triples we are getting for 2, and one pair of triple, and one triple we are getting for 3. So 2 into 2 into 2 in one bracket, then 2 into 2 into 2 another bracket, then into 3 into 3 into 3. Then last step is take one prime factor from each triple and find their product, which means that 2 into 2 into 3, which is equals to 12, and that's our final answer. So which we can what we can write over here there, that 12 is required to be the cube root of 1728. That's our final answer. So cube root of 1728 we got as 12. So in this way we have to proceed to find the cube root of any given number with the any perfect cube with the help of prime factorization method. Next is let's see how we can find the cube root of a negative number. Okay, so let's discuss this with the help of an example. For example, we have seen that the cube of a negative integer is negative. Okay, for example, minus 5 whole cube is nothing but minus 5 into minus 5 into minus 5, which is equal to minus of 125. Okay, so if someone asks you to find the cube root of negative 125, okay, that the answer will be minus 5 only. Okay, and what is the way to write is you have to write in this way, that cube root of negative 125 can be written as minus sign you can take out of the root. Okay, then only you can represent it as cube root of 125. So whatever you are getting the cube root of 125, that is 5 only. Then in the second step you have to multiply that answer with negative 1 only. So in this way you can observe that we are getting the cube root of negative 125, we are getting as negative 5. Okay, so in general, for example, if x is a positive integer, then cube root of minus x will be equal to minus of cube root of x. So this minus sign, always you have to take it out before finding the cube root of that number. Okay, after taking that minus sign out, whatever you are getting after finding the cube root, just multiply that with minus 1. That will be your final answer, or we can say that will be the cube root of that number. So to find the cube root of a negative number, find the cube root of its absolute value. Okay, absolute value means without negative sign. So negative sign, you have to keep it out of the root. So we have to find the cube root of its absolute value without the negative sign, then put a negative sign before it. Okay, the examples we have seen in the above cases. So next we'll discuss yeah, for example, now we'll discuss a few more examples. Over here you can see cube root of product of integers. Okay, so the example is we have to find the cube root of 64 into 125. So all of you know that the factors of 64 will be 2 6 times we have to multiply. Then factors of 125 we can get 5 into 5 into 5. So all of you can observe that we are getting uh, two triples of 2 and one triple of 5. Okay, so what we can write from there, that 2 into 2 into 5, that will be the multiplication will be the cube root of 64 into 125. So in this way we can find the cube root of product of integers. Okay, so one more thing we can notice that this root of cube root of 64 into 125 we can write also as, we can separate it and we can write cube root of 64 multiplied by cube root of 125. So separately also you can do. Okay, so cube root of 64, we know that that's 4, and cube root of 125 is 5. So that also you can do separately, otherwise you can do in multiplication form also. So in general you can observe this last statement over here, that cube root of AB can be written as cube root of A multiplied by cube root of B. So in this way we can find the cube roots of product of integers. I hope it's clear to all. Next topic is cube root of a rational number. Okay, so we have seen earlier that a by b whole cube is equals to a cube by b cube. Okay, so it follows from this that cube root of a upon b, that will be equal to cube root of a divided by cube root of b. So what we can observe that we can distribute the cube root in the numerator as well as in the denominator. So cube root of a by b can be written as cube root of a divided by cube root of b. For example, find the cube root of 729 by 1331. Okay, so what we can do from here, we can find the separate cube roots of numerator as well as for denominator. So for numerator 729 we are getting. So for 729 you can see that when we are finding the factors, we are getting two triples for 3, and similarly for 1331 we are getting one triple for 11. So for numerator, the cube root of 729 will be equal to 9, and for the denominator the cube root will be equal to 11. Okay, then we can simplify this. So 9 by 11, that will be our final answer for the cube root of 729 by 1331. That will be also in the form of rational number. Okay, students, so that's all for this chapter. So let's summarize what we have learned today in this video class. The first topic was the cube of a number is the sum of the number raised to the power of 3. Then we discussed about a cubic number, or a perfect cube is a natural number which is the cube of some natural number, for example like 8, 27 or 64, 125, so on. Then we are having a perfect cube can be expressed as the product of triples of equal factors, right? Then we discussed about the cube of an even natural number is even, and that for an odd natural number is odd. Then the cube of a negative integer is always negative. The cube of a rational number is always rational. Okay, for example, a upon b whole cube, that will be equal to a cube by b cube. Then later we discussed a few more concepts regarding the cube root of a given number is that number whose cube is equal to the given number. Okay, then the cube root of a negative number is negative, and the cube root of, for example, ab can be written as cube root of a into cube root of b. Okay, then the cube root of a rational number a by b is given by cube root of a into divided by cube root of b. So students, that's all for this video class. I hope all of you understood the concepts regarding cubes and cube roots. So in our upcoming sessions, we can easily do the problems in our exercise and textbooks regarding this chapter. So all of you go through this video lesson and do like and share the videos, and subscribe the channel for further more interesting videos regarding mathematics for grade 9 to 12 onwards. So that's all from my side in this session. Wish you all the best, and let's meet in our next session. Assalamu alaikum to all of you. Thanks a lot for watching the video.